We've got one final talk in this section before we move on, again focusing again on this idea of just a member of the band. We have Chanuki Seresinhe. She's a data scientist researcher at the Alan Turing Institute and the lead data scientist at Popsa. She formerly worked as a senior data scientist at Channel 4. Her research entails using big online data sets and deep learning to understand how the aesthetics of the environment influence human well-being. Really excited for Chanuki's talk. Please join me in giving her a huge round of applause.
I just started coughing earlier, so hopefully I won't break into a massive cough. But so many of you will probably find the story quite familiar, that you go on holiday, you take a bunch of photos, and you have all these grand plans of what you're going to do with those photos. You come back from holiday, and nothing absolutely happens to them because you're just so busy, you just don't have time. And so one of my roles is as lead data scientist at Popsa. And at Popsa, the idea is to try to simplify the process of making photo books and automate the process as much as possible. So even right now, you can actually create a photo book in a matter of a few minutes, not several hours. But we actually want to use AI to take this even further, where we actually use AI to automatically discover stories in a person's entire library. So how do we do this? So first of all, we've got to discover where that interesting story might be in your photo library. Now, you probably don't like the idea of your entire photo library going to a company for analysis. So the challenge for us is to actually try and do it as much as possible on a user's phone. And this is challenging because we only have a few seconds, maybe a minute, to actually do this process while somebody's kind of using the app. Like, we can distract them with a nice little video or something while we're doing analysis in the background. And what's interesting about this approach is that it actually protects the user's privacy. And so it just makes them feel a little bit more comfortable about engaging with Popsa. So say you've been on holiday, and we've noticed that there was you took a cluster of photos recently, and we're thinking, oh, okay, so this might make a really good photo book. But how do we actually know that you actually did go on holiday? Because maybe you just took a bunch of photos because you were just taking a bunch of selfies of yourself, just wanted to see what you look like. And also, how do we know what type of holiday you've been on? So we want to kind of create this photo book, but we need to know, are we creating a beach holiday photo book? Are we creating a ski holiday photo book or a city break photo book? And this is where we need to try to do something to actually analyze images. And this is where neural networks kind of come to the rescue because they've been so amazing at computer vision tasks. So for anybody that didn't come to the AI primer quiz last night, I'm going to just do a quick sweeping overview about what neural networks are and how they work. So just so you understand it intuitively. So just say that you want to write a computer program to tell the difference between zeros and sixes. Now, one way of doing this is to write a bunch of rules. So you can write an enormously long computer program with all these different rules to help it understand what it is that's different between a 0 and a 6. But you haven't even gone to the 1s and 7s, and now you have to write in another set of an enormous amount of rules. And this computer program will just be too slow to process anything useful. And that's how we had done stuff ages ago. Another way of actually creating an algorithm to learn something is to help it automatically learn the rules by itself. So just like you might teach a child to tell the difference between a cat and a dog, you point out, that's a cat, that's a dog, and you do that enough times, then the child is learning in the same way that a machine learning algorithm actually learns the rules by itself. And one of these machine learning algorithms is actually neural networks. And I specifically work with a deep neural network called convolutional neural networks. And convolutional neural networks are really interesting because they can actually learn how to see patterns, and that's how they actually distinguish what types of different images are. So they're pattern-like seeking algorithms. So, for example, in this example, it might be lines and loops in the sense of trying to understand different numbers. But you can actually build these layers quite deep, and so they might start to understand that different facial features, such as eyes and noses, are actually belong to someone's face. And so these networks can be incredibly deep, like hundreds of layers long, and they do incredibly well. So this is the kind of convolutional neural network that would use for an image like this, and that's where I have, so it's kind of confident that 99% it's a dining, eating photo, 55% confident it's a holiday, not 100% sure, because there's only a little bit of beach in the background. And then we can use this information to actually understand what kind of holiday somebody's been on. So that's one of the things we do. But could we actually use a neural network to actually understand something a bit more subjective? For example, something like aesthetics and beauty. So I've got another hat, and I'm continuing my research I did with my PhD at the University of Warwick and the Turing Institute. So I'm still a researcher as well at the Turing Institute, where I'm looking at the connection between beautiful places and our well-being. And for this research, I used this website called Scenic or Not. And on this website, people just rate these images between 1 and 10. But what's happening in the background is that I have an image for every square kilometer of Great Britain. So I've got about 17,000 images that have been rated about 1.5 million times. So this is a really great data set on beauty, beautiful places. So I wanted to first understand, well, what does beauty mean for people? One of the first things I did was, again, pass the images through a convolutional neural network, and this one's called MIT Places. And from this convolutional neural network, I can extract two things. So I can extract a place category, for example, if it's coast, ocean, or boardwalk, or whether it's a skyscraper or a tower, like an office scene. I can also extract different scene attributes, for example, if it's an open area, if it's man-made or natural, and all kinds of different things. So there's maybe around 400 different characteristics I can extract from each image. So I put in my 217,000 images through this algorithm, did a statistical analysis to understand what do we think is actually beautiful. And I found some interesting patterns. So unsurprisingly, of course, we do find scenes like coast, valley, mountain, forest, trees as being beautiful. Right? Tons of these scenes in Scotland. But surprisingly, we also see scenes come up that are man-made features, for example, cottage and lighthouse. So there's something about characterful buildings that also seem to add beauty to the scene, as well as bridge-like structures such as viaducts and aqueducts. When it comes to unscenic images, unsurprisingly, we do see images such as industrial highway as things that are coming out as unscenic. So people rate down the images when they see such features in the image. But I thought this one is interesting because they also came up with no horizon. And this might be driven by the fact that, so some people argue that our beauty preferences might be driven by evolutionary preferences. So if it's no horizon, we can actually survey our surrounding, and that might mean that we feel unsafe. So this could be a sign that this is kind of a collective preference that's actually driven by evolution. I can't prove that, but it's just an interesting theory. But surprisingly, we also don't seem to like flat areas of grass. And I found this actually quite fascinating because there's a lot of debate in policy, basically. They want about green space, but people rarely talk about the beauty of that green space. So what I wanted to do is, it was kind of clear that human beings, even though they do have individual preferences, that there are some kind of collective themes going on here. So there is some kind of understanding of beauty that we have. So I wanted to know if we actually can train a neural network now to understand beauty. And so I actually I taught this algorithm, like I mentioned before, like you teach a child, and you fed all these samples and all these examples that we've rated to help the neural network learn what we think is beautiful. And then I wanted to see, will it come up with something that's actually quite intuitive? So I took images all around London. I'm sorry it's London-centric because I didn't have images of Edinburgh. And I just wanted to see whether it kind of tied in with what I intuitively would find beautiful. So an area in London I quite love to hang out in the summer is Hampstead Heath. It's this absolutely stunning park with really wide sweeping views. And so I took a bunch of images around the area and I asked it to predict the rating. So purple is very scenic and green is scenic and gray is not scenic. And you'll see all around Hampstead Heath, the neural network has recognized there's a lot of beautiful images around here of this park. And one of the images it's picked up on being beautiful is this beautiful scene of the Hampstead Heath ponds. If we go hone into central London, it's not only picked up the parks, but what I thought was really interesting because there was this little path, and I was wondering, what is that path, that it's actually picked up on? And it turns out it was Regent's Canal, which is also just a really lovely walk to take on a lovely summer's day. So it wasn't just picking up on the greenery, it was actually starting to understand something a bit more complex. But it was smart to also know that it's not all natural scenes that should be beautiful. Here we have kind of really flat areas, really flat grassy area. There's it's next to a road network, and it realizes that this kind of scene, even though it has nature in it, is actually not beautiful. And it not only knows that nature can be beautiful, it also knows that we also like characterful buildings. So Tower Hill has a lot of historical buildings, and the neural network thinks that we might find it beautiful. And it's picked up on this picture and rated it as being beautiful. So it turns out that that beauty isn't in the human beholder's eyes after all. We can actually train an AI to understand beautiful places to an extent. And I think that was quite fascinating because it was something that when I was first thought about doing it, I really thought it was impossible. And I'm absolutely fascinated with the variety that the neural network can actually understand, and it can understand this nuance of beautiful places quite well, which is very surprising. So back to our story with Popsa. So, we can actually automatically discover stories. We can even go so far as to lay out this beautifully designed book. We can, we know what kind of holiday you've been on. We can choose the most beautiful pictures and showcase them. And we can pretty much do everything for you with the AI algorithms. But is this actually a good idea? And this is one thing I just want us to really think about, is actually being creative is something fun. And if we took that away from our customers, they won't actually enjoy using our app. So one thing we have to be very careful about is how the AI and the human interaction actually works together. So I would rather suggest things to the human, and have people actually decide on what they want to include, because then it gives you ownership and you actually enjoy the product a lot more. So I will be speaking on the next panel, and I would love to kind of introduce that story, actually thinking about how we actually want to use AI in creativity. But thank you.